In this demonstration, we shall see how convergent modeling workflows can be incorporated in the latest release of NX Algorithmic Modeling. We were unable to remove the sharp edges from this waffle board pattern in the previous versions of algorithmic modeling on which this was built. Even interactive methods of face or edge blends would require considerable effort to create the patches where the blends change convexity. To overcome this challenge, we shall add to this feature some of the new convergent body nodes available in this release of NX. With these nodes, we shall convert this sheet to a convergent model and then apply a smoothing effect to achieve our desired results quickly. First step would be to apply the new convergent body from body node on the sheet body output of the existing rule snippet. We modify the maximum deviation to 0.1 millimeter and the output looks acceptable on visual inspection. Next, we shall subdivide the facets to ensure the fineness of the smoothing effect on the sharp edges. Convergent body subdivision requires several inputs, one of which is the edge length. We shall introduce a third new capability, the convergent body information, which provides the average edge length currently in this convergent body. Now we can provide an input refinement factor that would control the edge length of the subdivided convergent body based on the current edge length. We shall change the angle threshold from 30 to 10 degrees and set it up for shape optimization. Let me reorganize the nodes a little bit for better understanding. Now we are ready to smoothen this convergent body. I'll bring in the node for smoothing it, and our final output would be from this one. When we smoothen the convergent body, we need some inputs. One is the smoothing factor. I'll create an input for that. Again, the number of iterations, we can keep it as 2 at this time. All these inputs can be changed at any point in time later on. And yes, I would want to lock the boundary and finally provide the input for the convergent body. I'll switch on the output and we can see how it looks like. Now obviously it requires some improvements. So what I'll do is we'll go to the rule inputs and rearrange the input fields. I check the inputs and I'll change the refinement factor to 4, which will create many more subdivisions and hence allow for a much more refined and granular convergent body. The smoothened body is now ready, and if I'm satisfied with the quality, I can exit the algorithmic modeling interface so that we can change the settings from the feature tree at any point in time later. This concludes our demonstration on the new capabilities of algorithmic modeling for convergent body support.